Hi, my name is Jessica Chen, and I'm currently a fifth-year bioengineering student at Northeastern. Through the CaNCURE program, I have been working in Judy Lieberman's lab at Boston Children's Hospital for the past 6 months, investigating caspase-mediated activation of the IL-1 protein family. The background of this project is focused on caspase-4 primarily, which is a member of a family of inflammatory proteases that are heavily involved in inflammation and cell death. The Lieberman lab does a lot of work involving one type of programmed cell death in particular called pyroptosis. Pyroptotic cell death is different from apoptosis and is characterized by the formation of cell membrane pores and the subsequent release of inflammatory cellular contents. There are many cellular components involved in pyroptotic pathways, but here we are focused on gasdermin D and caspase-4. Gasdermin D is a primary executioner of pyroptosis, as its cleaved N-terminus forms the characterizing membrane pores. Caspase-4 is a non-canonical activator of gasdermin D and also mediates the release of certain inflammatory cytokines. Not all of its substrates are known at this moment, but my mentor has used a novel method to identify potential caspase-4 substrates, and one of those he identified was a protein called IL-36G. IL-36G belongs to the interleukin-1 protein family, or IL-1 protein family, which is comprised of 11 proteins in total. About half have anti-inflammatory functions, and the other half have pro-inflammatory functions. 9 of these 11 proteins are known as inflammatory cytokines, and they perform a variety of immunological functions within the body. These relate to allergens, autoimmune diseases, asthma, and psoriasis, for a few examples. Identifying any of these proteins as additional substrates of caspase-4, as well as the potential cleavage sites and if the proteins are inactivated or activated, could illuminate additional roles that caspase-4 plays in the immunological functions and would open a door for more research into the physiological importance of these interactions. So, the main objective of the project I've been working on has been to investigate caspase-4 mediated cleavage of the IL-1 family proteins. To do so, I utilized a large number of laboratory methods. Much of my early work involved plasmid design and construction, which included designing primers, performing PCR and Gibson assembly to create the plasmids containing the IL-1 proteins, and then transformation, mini-culture, and mini-prep to purify the plasmids. From there, I performed isolation and purification of the full-length IL-1 family proteins to use in vitro cleavage assays, along with recombinant caspase-4. I then ran a number of different protein expression assays, such as Western blot, Comasi blue, and silver stain, to analyze the molecular weights and determine if the proteins had been cleaved. Through my time in the lab, I also did a lot of cell culture with multiple cell lines and performed transfection of HEC293 T cells. I learned many technical skills in my time here, as I did not have any experience with most of the methods I just outlined prior to this co-op. For those I did already know, like cell culture, this job has helped me develop those skills further. I also gained a lot of technical knowledge regarding protein interactions and cell mechanisms, and cultivated my own understanding of immunology and pyroptosis in particular. I would say the most important lesson I've learned has been one of trial and error. It's an inevitable obstacle in any job, but I learned so much about always seeking new perspectives in the lab, as there were a lot of theories tested and then new theories created out of those results during my time here. My confidence in the lab and in giving scientific presentations has also been developed quite a lot. Finally, looking ahead, I hope to build upon this co-op and spend more time in a lab space in the near future as I consider options for a PhD, as this co-op has definitely reaffirmed my interest in research and in cancer research in particular. The areas I'm currently interested in are immunology, genetics, and cancer research. I would like to thank Judy Lieberman, my PI, for all of her mentorship and guidance throughout this process. I would also like to thank my daily mentor, Shiyu Ma, for being such a great teacher, and to everyone in the Lieberman lab for their support. Thank you also to Anne, Nita, and Keenan, and everyone at Northeastern's CaNCURE program for making this opportunity possible. And of course, thank you for listening.